Yeah, 9.5 are all about adding and subtracting rational expressions. So, as a quick warm-up, a review of fractions is in order. So, go ahead and hook up these 3 warm-ups. Press pause, and we'll check back in a minute. All right, so hopefully, in order to add or subtract fractions, you need a common denominator. In this case, the common denominator is 3. So 2 minus 7 is negative 5 thirds. 2 thirds minus 7 thirds. You have 2 of these third things minus 7 of these third things. You have negative 5 of these third things. It's just like combining like terms, where the like terms are the denominators. Now, 5 and 3, what would be the common denominator? Well, 5 and 3 can both get at 15. So I'm going to multiply this one by 3 divided by 3. This one by 5 divided by 5. Negative 12 fifteenths plus 35 fifteenths is 23 fifteenths. All right. Then this one, oh snap, it's got an x in there. Doesn't matter. It's got a common denominator. 3x minus 3 divided by 2x minus 7 divided by 2x is negative 4 divided by 2x. But of course that reduces to negative 2 over x. Very similar to what we did yesterday. Alright, so we're just going to be doing the same things. It's just that it's going to look harder, but it's no harder. Let's try this first one. Add or subtracting rational expressions with unlike denominators. Now here's the thing. These denominators certainly are nothing alike. But just like yesterday, the first thing I want you to do is I want you to factor it whenever you can. Whenever you can, factor it. So this is going to be 4 divided by 3x cubed plus x divided by 3x squared can come out, and we're left with 2x plus 1. Okay, so look at these denominators. The denominators are 3x to the third is this one. Now this one has a 3, just like this one does, but it only has x squared. So what's this one missing? This is x squared. It should be x to the third. So this one is going to need an x for sure. This one needs an x so that we have 3x to the third. But this denominator also has this 2x plus 1, which the first fraction is missing. So this is going to need a 2x plus 1 on top and bottom. And now, hopefully that you can see our denominator, our common denominator is 3x cubed times 2x plus 1. They each had 3's. They almost had 3 x's, or x cubed, but this one needed an extra one. And then the third thing that they don't have, or that this one needs, that this one has, is 2x plus 1. That's our common denominator. So just like in the second warm-up, we're going to multiply this together. So this becomes 8x plus 4 over 3x cubed times 2x plus 1 plus x squared divided by 3x cubed times 2x plus 1. All right, now they have a common denominator, so we can add these together. We got x squared plus 8x plus 4, excuse me, put it in standard form, over 3x cubed times 2x plus 1. Now, once we've put this together, check to see if this factors further. There might become a time where this will factor and then something will cancel, just like yesterday. So in this case, does anything multiply to 4 and add up to 8? No. So in this case, turns out that is our final answer. All right, just like anything else, you need a common denominator in order to add or subtract. Let's go on to the second one. X plus 1, factor first. What multiplies a 9 and adds up to 6? X plus 3 and x plus 3. Minus 1 over x plus 3, x minus 3. All right, now what's going to be our common denominator? In this case, we have 2 x plus 3's. This one only has one x plus 3, but it also has an x minus 3. So what do you suppose our common denominator is going to be? Our common denominator is going to be three things here. It's going to be 2x plus 3's, because this one has 2, so this one needs 2. X plus 3 and x plus 3. And then the other element is x minus 3. That's going to be our common denominator. So what is this first one missing? This first one's missing an x minus 3. So we need to add, I'm going to do that in green again, x minus 3 and x minus 3. What's this one missing? This one's missing 2x plus 3's. It has 1, but it needs a third one. X plus 3 on top and bottom. Alright, now here's the thing. Well, let's go for it. We need to multiply the top, FOIL it out. Now, here's the thing. We're not going to FOIL out the bottom. Only going to FOIL out the top. Alright? The bottom is all set. The top's going to FOIL out to x squared minus 2x minus 3 over x plus 3, x plus 3, x minus 3 minus, now 1 times this is just x plus 3 over x plus 3, x plus 3, x minus 3. So we got a common denominator, so we can subtract these. Now here's the tricky part. Make sure you go x squared. Now this is minus this thing, right? Or plus negative this thing, right? So you need to distribute this negative to both terms here. This is going to be minus 3x minus 6 over x plus 3. Tell you what, just for the sake of writing, x plus 3 and x plus 3 is x plus 3 squared, right? X minus 3. Now again, look at this top. What multiplies a negative 6 but adds up to negative 3? In this case, nothing. So again, we're all set there. All done. All right. That brings us to page 2. This should have been on page 2. Complex fraction. What is a complex fraction? Complex fraction is a fraction in a fraction. It's like Inception, a dream in a dream, except there's a fraction inside a fraction. So, let's go on to number 3. This is fraction within a fraction. Excuse me. Now, look at the top. The top is this fraction. There's not much that we can do there, right? But the bottom is adding these two fractions. We need to put that together so we have just a fraction divided by a fraction. AB divided by CD. C divided by D. All right, so this bottom part, we need a common denominator. The denominator is x minus 4 and x plus 1. Our common denominator here is going to be x minus 4 and x plus 1. In which case, this is missing an x plus 1 on top and bottom. And this is missing an x minus 4 on top and bottom. So the top remains the same. 3 over x minus 4 over, this is going to be x plus 1. Now here's the thing. We know that we have a common denominator now. I'm going to make our common denominator x plus 1 and x minus 4. And then the top is going to be x plus 1, this x plus 1, plus 3 times this mess. So plus 3x minus 12. Take a minute. Do you see where I got that? Common denominator is all set. So the top part of this is going to be x plus 1 plus 3 times this thing. All right, so now we're at 3 over x minus 4 over 4x minus 11 over x plus 1 x minus 4. All right, now it's a complex fraction, but it's less complex because now, look at it now. I have this fraction where nothing else can be done to it, and then I got this fraction where there's not a GCF. I'm all set. But here's the thing. This is just like a division problem. What we've got here is 3 over x minus 4, but instead of divided by this mess, we're going to multiply by the reciprocal of the denominator. So this is x plus 1, x minus 4, over 4x minus 11. Alright, now since we're multiplying here, x minus 4's can cancel. And we're left with 3 times x plus 1. Don't worry about distributing it. Who cares? We're all set here. Divided by 4x minus 11. Remember, we're hoping that more things will cancel. So if you distribute, it's hard to see if things cancel. That's why we don't distribute the tops. All right. So that is our final answer. All right. Tell you what. Try 4 and 5. 5 looks scary, but it's not that bad. And we'll talk about them during class. Smith out!